In this first question, we'll be creating some hardware with our microcontroller. So we start off with drawing our microcontroller in the middle, and it's got a 3.6 volt supply, and we have a decoupling capacitor that goes to ground. At this sort of frequency, our decoupling capacitor will be 100 nanofarad, and I mentioned a 3.6 volt supply. So our first section's done. We then have LEDs connected to P1.1 and P1.0. We connect up LEDs using the standard configuration of we have our supply, we have a current limiting resistor, and then we have our LED. So we'll have our other one over here. So two LEDs, P1.0 and P1.1. We then have some switches on P1.2 and 1.4, and another switch with the internal pull-up resistor on 1.7. Just so I can fit it in easily, we might put the switch here, P1.7, without the pull-up resistor, and we might put the two switches on the other side with the pull-up resistors. So there's one and the other one. And they're on P1.2 and P1.4. So we have all our switches, we have our capacitor in place, we have our LEDs in place. We just need to calculate some current limiting resistors for these resistors, so R1 and R2. We'll say R1 is equal to R2. Now we're not given a V output low max, so in this case we'll assume it's 0. So we can say that's equal to 3.6 volts supply voltage minus 1.8 volts, which is the forward voltage of the LED, divided by 0.012, 12 milliamps, and that will give us 150 ohms for our two resistors there. Our pull-up resistors here should be between 10k and 100k, which allows us to pull up our pin, so we have enough current to be able to pull it up, but when we actually press our switch, our pin won't be shorted. And one little mistake I found over here, we should have actually had our switch in there and not just a ground connection. Okay, in this next question we're going to write a function to set up those pins that we had before from question 1. So we'll call our function something logical, void init IO, so it's going to initialize the inputs and the outputs. Now we're not supplying any parameters to it, so we put void in there, and we're not getting any return value, so we have void over there as well. Okay, first thing we need to do is set up the direction of the pins, so P1 dir is equal to 0x6b. In binary this is 0110 1011. You can match those up. We then need to enable the pull-up resistor on P1.7. So P1 resistor enable equals 0x80. We could have also just said bit 7. That might be a nicer way of presenting it. And then we also need to set the P1 output for that particular pin to be high, because when we're using internal pull-up resistors or these pull-up or pull-down resistors, if P1 out equals low, it's pull down. If it's high, it's pull up. So we say P1 out equals, and in this case we'll use the other notation and say bit 7. Okay, we could have changed it with 80 in hex as well. Okay, now we need to write some code to get that LED to toggle slowly enough that we can actually see it. And we'll need to write a delay function as well. So we'll say void main So we've got our main function here. So we need to flash that LED on and off. So we say P1 out, we use XOR to flash it, and here we'll just use the notation bit 0. We could have also put 0x01. We've done the same thing. And then we need to delay. Okay, we've got that delay. We're calling a delay function here. Let's actually write the delay function. So we say void delay, no parameters we're passing to it or from it. Now we need to delay for 50,000 cycles, so we'll need to use an unsigned int. If we use the signed int, it would only allow us to go up to 32,767. So we say for I equals 0, I is less than 50,000, I plus plus, we delay, and then we're finished. Okay, next one. We want to turn all the LEDs on if the button at P1.4 is pressed, or off if it's not pressed. So we'll write our void main again. And we'll have an if statement. Now remember, we're always checking it against 0. We want to know if the button's pressed. So if equals, and we're saying P1 in and bit 4. So that will be true if the button's pressed. We want to turn all the LEDs on. So LEDs are on P1.1 and P1.0. So we need to AND them with bit 0 or bit 1. And we need to invert that. We need to then say else we need to turn it off if they're not pressed. So P1 out or equals, so we need to set them high, and we can say bit 0 or bit 1. One thing I neglected to mention, these should all be within a while 1 loop, so they actually keep looping. So that one should be while 1 as well. So we'll do the same with this one. We'll start off with declaring an integer. We'll then say while 1, we create our infinite loop that we perform our executions inside. And what we want to do is we want to check if the button's pressed. So we can say if 0, well, first we'll check if it's not pressed. If 0 is not equal to P1 in and bit 7, I equals 1000. So we'll reset our timer there. If that condition is not true, well then the button must be pressed. And so what we want to do is we want to decrement our counter, and we want to keep decrementing our counter, or I, until it becomes 0. Once it becomes 0, we can toggle our LEDs, and then we just have to wait and make sure the button's not still pressed, otherwise we'll go through this loop again and the LEDs will just be flashing on and off. So we can say I minus minus, or I equals I minus 1. We then need to check if I equals 0. So if 0 is equal to I, now if it's not, we go back through our loop and go through all this again and decrement I again if it's still pressed. So if it is equal to I, we can say P1 out XOR equals bit 1 or bit 0. Then we say while 0 equals bit 7. So while the button is still pressed, we just want to wait there. That will stop us flashing on and off, on and off, on and off all the time. Okay, there we go. So just a quick recap, we check if the button's pressed. If the button's not pressed, we want to set I equal to 1000. If it is pressed, we step into this section and we decrement I. Just missing one bracket. We decrement I, we check if I is equal to 0, we invert there, and then we wait in this section. Okay, for this final question we're doing a Fibonacci calculator in C. So we'll start off by creating some variables for our current, previous and next values. So we'll create them as unsigned, which is the same type of variable that we're having as our return value. We'll call them prev, current and next. And prev should be 0. Current should be 1, and well, we'll be calculating next as we go through. So we'll create a loop here for int I equals I is less than fib number, I plus plus. Okay, now we just need to do the basic Fibonacci part. So we say next is equal to current plus previous, and then we do the shuffle. So previous is equal to current, current is equal to next, and we close our for loop. So once we've run through that I number of times, or fib number of times, we have our results and we return it. We return the current value and we close.